welcome to the first lecture of module 3 of game theory and economics. What we have done so far, let me recapitulate what we have done. We have introduced the idea of game theory, what it means and what are the basic assumptions of this whole premise of game theory. And we have also in module 2 discussed what is known as a Nash equilibrium and what are the assumptions, conditions of Nash equilibrium. We have also talked about equilibria like symmetric equilibria when they are applicable, symmetric Nash equilibrium. We have also talked about things like dominated actions, strictly domination, weakly domination, and what are the examples of such domination. And we have also discussed various examples, how to find out the Nash equilibrium in a particular game. And we have talked about best response functions also. We have seen that best response functions can be useful in finding out Nash equilibria, especially when the number of actions is more than one, and in fact if it is close to infinity, then we do not have any other way but to depend on best response functions to find out the Nash equilibria of a particular game. What we propose to do in module 3 in this module is that we are going to discuss various applications of game theory. In particular, we shall be talking about 6 applications. The first 2 applications will be from the domain of economics, and these are number 1. Cournot oligopoly model. Oligopoly model. So, these will be from the subject of economics. Then we shall be talking about what are known as electoral competition. So, this is from political science, and of course, in economics also there is a sub-discipline of economics called political economy. There also these models of electoral competition are used. Then we shall talk about what is known as war of attrition. We shall discuss auctions. And finally, accident loss. So, this is from economics, this is from economics, this is from political science. This is mainly from biology. This is auction theory. Auction theory is studied as a part of economics itself, and finally this is law. So, what we are trying to do here is to look into different subjects like economics, political science, biology, etc., and try to see whether Nash equilibria, the idea of Nash equilibria gives us any hint, or does it give us any fruitful prediction as to what outcome will occur in each of these 6 cases. There can be more than one outcome, of course. So, just to briefly talk about these 6 cases, in first and 2 we are going to talk about oligopoly markets. What are oligopoly markets? Well, in economics, when we study markets, we divide markets generally depending on the number of producers. We assume that the number of producers is same as the number of sellers. So, there is no difference between a retail seller and a wholesaler and a producer. We assume that just the producers are producing their goods and selling it in the market without any intermediary of a separate layer of sellers as such. So, in economics, the markets are divided according to the number of sellers. In monopoly, there is a single seller. In perfect competition, that is at the other extreme, there are infinite sellers, or you can think about a very large number of sellers, that is called perfect competition. In between, we have this case of oligopoly. So, oligopoly is the case where the number of sellers is not one, more than one, but it is not a very large number either. So, we can say it is a few number of sellers, are there, and they compete within themselves. But the question is, how do they compete? And depending on the answer to that question, how do they compete, we can divide the markets into two, oligopoly markets into two kinds of market. One is the Cournot market, or which we shall be studying here in Cournot oligopoly model, and the second is Bertrand market, which we shall also be studying. The difference is that in Cournot market or in Cournot model, the producers are deciding on their production level. They are not deciding on the price. Price is determined in the market. So, price is outside the control of the sellers. On the other hand, Bertrand market, or in Bertrand model, the producers are deciding at what price they are going to sell their goods, but how much they are going to produce, that is going to be decided by the market condition. So, in first case, it is the quantity of goods that the producers are producing, that is in their control. In the second case, it is the price which is in their control of the producers, but both are the cases where the number of producers is few. Few is a vague term, but nevertheless we do not have any precise definition as far as the number of producers in oligopoly market is concerned. Okay, now in third topic, that is electoral competition, we are going to talk about how the candidates in a vote, in an election, decide on their agenda depending on the preferences of the voters, and can we predict what agenda they will pick up and what will be the equilibrium. In the fourth case, we are going to talk about war of attrition. Here, suppose there are two competing parties who are competing over some common resource or common target. For example, it might be two hunters targeting the same prey. Now, these two hunters will then like to inflict damages on each other, because only one of them will going to get the prey. So, this kind of competition between players who are trying to get a common resource or common prey will be studied in war of attrition. We can think of this case as not hunters and prey, but we can think of this as two companies who are fighting over a very valuable employee, for example, and they are trying to employ that particular employee by outsmarting the other player. Fifthly, we are going to talk about auctions, where auctions is very commonly used term. The players are trying to again trying to get the same resource or same commodity, and they are trying to get that commodity by bidding. It might be, there will be different kinds of bidding that we are going to talk about. You can see that there is some similarity between war of attrition and auction, because in both cases the object that the players are after is the same, and the players are basically fighting within themselves to get that object. And finally, in topic 6, we are going to talk about accident laws. So, if an accident happens, there is one victim and one person who has caused the accident. Let us call that person to be the injurer. Now, it is easy to figure out that if an accident happens, maybe some blame of the accident lies with the victim, and a part of the accident also lies with the injurer. For example, if a pedestrian is crossing a road and a car runs him down, then the blame may lie in either side. It may be lying in both sides also. For example, the pedestrian might have been careless while crossing the street, or the car might have been very rash. So, in such cases, how shall the state, how shall the government frame the laws such that this kind of accidents, when they happen, the damages that have to be paid by each or borne by each are fairly distributed. So, we are going to talk about those laws, which laws are most efficient and which are not. So, in all these cases, we are going to use the idea of Nash equilibrium and game theory to see whether we can predict the outcome in the real world through our tools of Nash equilibrium and game theory. So, let us start with this Cournot oligopoly model. As I have just said that it's going to be a model of market. So, in a market basically there are two sides in a market. One is the side of the sellers who are producing the good and selling it in the market, and then there is the side of the buyers, the people who are demanding the goods. Before we go into the details of this Cournot model, let us be clear about the general structure of this model, oligopoly model as such, and in specifically Cournot model. What we are going to assume that suppose there are n producers, n is any number greater than 1, but not very large obviously, and suppose the outputs, or let us say output levels of producers are suppose Q1, Q2 Qn, where Qi is any number between 0 and infinity. I goes from 1 to n, all right. And we are going to assume that the goods that they are producing are homogeneous. What does it mean? It means that producer 1, the output that he is producing it looks exactly the same way as the output of producer 2, as the output of producer 3, etc., etc. So, it means that there is no brand name as such, there is no label over the products that the producers are producing. So, it is not like you have the cold drinks market, and in the cold drinks market you see different brands of cold drinks produced by different companies. So, you can make the difference between Coca-Cola and Pepsi, for example. But here we are going to assume that does not matter where the cold drinks are coming from. The producers are making the cold drinks in such a way that the buyers cannot distinguish between the product of one producer from the product of the other producers. So, that is why we have said that the goods are homogeneous, they are similar. Now, suppose Q, capital Q, is the summation of all these output levels produced by all the producers. So, producer 1 is producing Q1 amount of output. So, Q1 might be 30 and Q2 is the output produced by producer 2. Suppose Q2 is equal to 15 and let us suppose there are only 2 producers Q1. So, there are Q1 and Q2 only, there are no Q3 or Q4 etc., etc. So, here the total supply in the market which is given by Q, let us put S here to denote supply. So, Qs is the supply in the market, this Qs is equal to Q1 plus Q2, that is 30 plus 15 which is equal to 45. So, this is the total supply in the market. Now, once we have seen the supply side, now we must also talk about the demand side. When these goods are being sold, these 45 units of goods are being sold in the market, they must be getting sold at a particular price. Now, how is this price going to be determined? Let us suppose P is the price per unit of the good. Now, remember that P that player 1 gets, that producer 1 gets, must be equal to P that producer 2 gets, because their goods are exactly the same, they look the same way. If they look the same way, the quality is the same, then price also must be the same, because the consumers are not able to make the difference. So, they are going to pay the same price. Now, if price is P, then one may wonder how this price in the market is being determined, at what price this Qs is being sold in the market. To understand that question, to understand the answer to that question, we must look at the demand side now. So, demand. Well, to make things clear, what we say that in the market, that there is a law of demand. What does it mean? That quantity demanded inversely related to the market price. So, suppose Q is quantity demanded, now when we say Q is quantity demanded, QD is the quantity demanded in the entire market. So, think about this, that there is a rice market and the number of producers are there and they are selling the rice in the market, and from the side of the consumers, the customers, they have their demand for rice. Suppose at a particular price level 20, suppose price level is 20, I am demanding 5 kilo of rice, the other people are demanding in total 100 kilo of rice. So, the total market demand at 20 rupees per kilo will be 5 plus 20, that is 5 plus 100 is equal to 105 kilo of rice. So, that is the total demand in the market, which we are denoting by QD. But the point is that this QD is not constant, it is not fixed. QD is going to be affected by the market price, In this example, when the price was 20 rupees, I was demanding 5 kilo of rice. But suppose market price rises from 20 rupees, it jumps to 40 rupees. Then I might find it economical to consume something else, maybe wheat. I may shift to wheat. Then I will not demand 5 rupees of rice. Maybe I will demand 5 kilo instead of 5. I will demand 3 kilo of rice. And other people who are demanding 100 kilo of rice, if the price goes up to 40 rupees per kilo, they might demand less. They might demand 60 kilo of rice. So, if the price in the market for any good rises, the demand for that has a tendency to fall, and vice versa, that is, if the price falls, then the demand might increase. So, there is an inverse relationship between price in the market and the quantity demanded. So, this is written as the following: QD is a function of P, where df dp is negative. All right. Now, a question may arise that if the commodity that I am demanding is extremely necessary, I cannot live without it, then if the price goes up, will I be able to cut down its consumption? Will I be able to demand less? Well, it is true that in some cases this law of demand, this inverse relationship between quantity demanded and price may not hold. People will not be able to cut down their consumption even if the price rises. Or it may happen the other way also. Suppose there is a good which I am demanding, but I do not like to consume a lot of it. So, I have reached the saturation point, so as to say, of that good, and in that case if the price falls, even then I will not be buying more of that good. Nevertheless, so there are these exceptional cases where quantity demanded may not respond to the price in the expected way. But overall, if we look at everybody's consumption, everybody's demand, sum them up, then there is a tendency, not always true of course, but there is a tendency that quantity demanded varies inversely to prices. So, that is what is known by this law of demand. So, we have two things now. One is quantity demanded, which is given by f p, where f dash p is less than 0, and the other is quantity supplied, which is supplied by all these people, all these producers. Now, before we go further, from here it is I can also write this taking the inverse of this. P is equal to F inverse of QD, that I can write, and so this can, in a very simple way, instead of F inverse, so P can be written as a function of Q, and this is known as inverse demand function. In demand function, what we had is quantity demanded as a function of price. If P was rising, quantity demanded was falling, and vice versa. In inverse demand function, it is just the opposite in the sense that we have taken the inverse. We are expressing P as the dependent variable on the quantity demanded, which is QD, and here also the same thing will happen. Because if there is a inverse function, if there is a function which is downward sloping and monotonic, and if I take the inverse remain a downward sloping function and monotonic. So, this is called the inverse demand function, but what is required in the market is that what is known as an equilibrium. What is equilibrium? Equilibrium demands that quantity demanded must be equal to quantity supplied. What does it mean is that if quantity demanded is not equal to quantity supplied, then there will be movement in the market and the market is not in a state of rest. The equilibrium, the notion of equilibrium, that it is a state of rest. In this context, of course, Nash equilibrium has been used, but it's in a different state of it was in a different context. In that case, the notion of Nash equilibrium, that was it was a steady state. Here, so the steadiness or stability is inherent in the concept of equilibrium. So, in this case, quantity demanded, if it is not equal to quantity supplied, take this case that in the market at the current price, suppose again the price is 20 rupees, quantity demanded is 100 and the quantity supplied is 50. Now, can this situation go on forever? Is this a state of rest? The answer is no, because if the quantity demanded is higher than quantity supplied, what will happen is that people who are demanding goods, all of them will not be able to get the goods. So, people are demanding 100 kg and the supplied is 50 kg. So, what will happen in the market, the demanders or the people who are demanding goods, they are going to push up the price in the market. So, P here is going to rise, it is not going to stay at 20 rupees. And so, since the P is changing here, it means that this is not a state of rest. And similarly, if just the opposite thing happens, suppose this is what is the case, the demand is less than supply, then what will happen, that the sellers who are taking all this 100 kgs to the market will not be able to sell this 100 kgs, because the demand in the market is only for 50. So, what they will do is to compete among themselves and they are going to reduce the price so that they are able to sell their goods. So, as a result, price will fall, and so again it is not a state of rest, there is a movement here. So, the moral of the story is that if and only if QD is equal to QS, we are going to have a state of rest, prices will not move, and that is known in economics as an equilibrium situation. So, in equilibrium, people who are trying to buy goods are able to buy goods, all of them at the prevailing price. People who are trying to sell goods are able to sell goods. There is no dissatisfaction as such. If there is no dissatisfaction, then there is no reason for price to move. So, this is the basic idea of market equilibrium. Now, here in our model, what we had is the following: QS was the summation of all these QIs and QD was a function of P. If I now impose this condition, equilibrium condition, QS is equal to QD, let us suppose is equal to Q, then we must have then summation QI equal to Q is equal to FP, right. and which means that P must be equal to we can write it QS also, and this is what we have denoted as P. So, what is happening here is that if I have to know what is the price in the market, the equilibrium price in the market, given that all these producers are producing Q1, Q2, Qn amount of output, what I need to know, what I need to do is to sum all these Qi's, get this Qs, all right, and put that Qs in this P function. And if I put that Qs, which is equal to Q, the equilibrium quantity, into this P function, I will get the equilibrium price. So, that is the crux of the entire thing. This gives me the equilibrium price in the market. This is this can be also be represented in terms of a diagram. So, this along the vertical axis we are representing price per unit. Along the horizontal axis we are representing the quantity, total amount of quantity that all these producers are producing together. I know the demand function will look like this. This is the demand function, downward sloping, and this is what is known as supply, Qs. This is the demand. And at the where they are equal is at the intersection point. So, this is the intersection point, and therefore, this, let us call this P star, is the equilibrium price. And you can see that as these producers changing their Qs, this equilibrium price is going to change. For example, if they decide to produce more output, then this equilibrium price is going to go down to P dashed, and it will happen the other way also. If they decide to produce less output, then it is going to shift this way and equilibrium price will go up. And what is happening is very simple, that all the producers taking together, they are producing certain level of output. If they have to sell that level of output, that quantity of output, then there has to be a particular given price. That price is the equilibrium price at which they will just be able to sell that level of output. If they now decide to produce more, then to make the buyers buy that extra amount of output, higher level of output, price must go down, otherwise the buyers are not going to buy. On the other hand, if they decide to produce less amount of output, then for all these outputs to get sold and for equilibrium to happen, it must happen that price must go up, because at the previous level of prices, if the output goes down, then there will be some unsatisfied buyers who are not getting their goods, even if they are ready to pay that P star amount of price. So, now the price must go up, so that there is no unsatisfied buyers and there are no unsatisfied sellers as well. So, that is what is happening here. Now, let us, this was the general story of a market equilibrium. This was just to introduce the basic underlying things to students who are not familiar with the market equilibrium model. So, in this Cournot model, what is our purpose of studying this model? Our purpose is the following. Firstly, we are going to find out how the outcome in this market, by outcome we mean what is the quantity which are being bought and sold, and at what price they are bought and sold. How this quantity and price are going to be affected firstly by the demand conditions. For example, suppose the consumers are demanding more goods, then how the price and quantity are going to be affected. Also the profits of the producers, how are they going to be affected. We are also going to look at the question, if suppose there are some technological advancement, for example, if the producers are now able to produce goods at a lower cost, then how is it going to affect the market equilibrium? Will the quantity of goods produced in the market going to go up? Is the price going to go down? What is going to happen to the profits? We are also going to look at the number of firms. I mean, if the number of producers go up or if it goes down, how is it going to affect the competition, in the sense that is the total quantity in the market going to go up? Is it going to go down? What is happening to prices? What is happening to profits, etc., etc. So these are some of the issues that we are going to address in this model. So there are in general n number of producers. We shall also call them firms. And when they produce something, output of a particular producer, this is the output of producer I. But when you are producing an output at level of output, then there must be some cost that you have to incur. So cost we are going to represent as Ci, which is also of course a function of Qi. So Ci is the cost. What more can I say about Ci? What kind of function it is? It is going to be an increasing function, because if the producer is producing more, if Qi rises, then obviously cost also rises. So Ci prime is positive. Now let us look at the profit of this producer. Let us call it pi I. Now, what is profit after all? Profit for any producer is the total amount of money that he is getting by selling his goods to the market. That is what is known as total revenue. The total amount of money a producer gets by selling his goods in the market, minus the total cost, the cost that he bears to produce that level of output, and this entire thing must be a function of Qi. So this, what is total revenue? Total revenue is the quantity I am selling, which is Qi, multiplied by the price that I am getting per unit, which is P. So this is the total amount of money I am getting by selling my goods in the market, minus Ci Qi. This is the cost, total cost that I incur to produce Qi level of output. Now what is P? P, now if you remember, is this. This is the equilibrium price in the market. This is the price which will prevail in the market if I produce Qi and other producers are producing their Qs. So it is a function of, there is a Qi here and Qn minus Ci Qi. So, this is the profit of this producer in general. So, here this is, remember, this P as a function of Q1 plus Q2 plus Qn is nothing but the inverse demand function. So, and inside that inverse demand function, not only Qi is there, but all the Q's are there. And here we have this inkling as to why game theory is important here. Now, we can figure out that pi I is not only a function of Qi, but it is a function of so many Q's, and which is the basic crux of game theory, that my preference or what I am getting out of this entire thing, it depends not only what I am doing, but it also depends on what other players are doing. So, what the producers are going to do here is they are going to trying to get as high profit as possible. So, each of them is trying to maximize this one, but this pi I which they are trying to maximize is not only a function of what they are doing individually, but it also depends on what other people are doing, what other producers are producing. And there is coming the element of interdependence. And since we have the idea of interdependence, people's payoffs are getting affected by the actions of other producers, we can profitably use the idea of game theory here and Nash equilibrium. So, let us write it down in terms of game theoretical model then. First is, who are the players? N producers, actions, output levels, because that is what they are deciding on output levels, how much they are going to produce, and this output levels can be any number between 0 and infinity. And preferences profit function Qi this is what they try to maximize. Now, what we are going to do in order to look and discern the equilibrium in this model, in this oligopoly model, is we are going to simplify it a little bit, in fact considerably. We are going to assume that n is 2, that the number of producers in this market is just 2. This is just to simplify. We are going to then generalize this model by taking n as any number greater than 2. Secondly, we are going to assume that Ci, which is Qi, is C multiplied by Qi for all I. There are only 2 firms, so I do not have to bother about. So, it basically means that the cost function for players are same, in the sense that their cost functions are represented by C, which is a constant. C is a number greater than 0, and the total cost is just that C multiplied by the quantity that they are producing. So, in a sense that this C, small c, is the unit cost of production. So, if they want to produce 1 unit of output, the total cost is C. If they want to produce n units of output, the total cost is just n multiplied by C. And we are going to assume that P, this is the inverse demand function. Takes a very simple linear form. This is represented by, suppose, equal to 0 if alpha is less than q. So, this is a very simple linear representation of the demand function. You can see that it is of course a downward sloping line. As q rises, this alpha minus q obviously falls, but that is true only when alpha is greater than equal to q. This is important because if q is greater than alpha, then this first formula gives me a negative, the first line gives me a negative p, and price can never be negative. So, the minimum value that p can take is 0, and which will happen if q is greater than alpha or q is just equal to alpha. So, this is represented by a diagram. Suppose this is p, this is q, then I have this downward sloping line. It is in fact a line which creates a 45-degree angle with the this axis, q dashed axis, and this intercept is alpha. Here also it is alpha, and this demand function is in fact this part plus this vertical part. So, this is the demand function in the market. So, this is again a simplified approach towards this oligopoly model. We have simplified a lot of things. Firstly, we have assumed that the number of producers is not in general n, it is 2. We have assumed a cost function which is again a constant term plus the constant term multiplied by the output level qi, and we have assumed a linear demand function. Now, after doing this, our model becomes simplified, and then how do I write the profit function? Now, before we write and profit function and try to find out the Nash equilibrium, let us be clear as to what we are trying to do. We are going to find the Nash equilibrium in this model. Now, how we are going to do this? Here what is happening is that the number of actions is infinite. If you remember, qi is the action, and qi can take any value between 0 and infinity. And if there are infinite number of actions, obviously we cannot just construct a payoff matrix and find out what are the Nash equilibria. So, what we are going to do is to find out the best response functions, and from the best response function of these two players, we are going to apply the idea that the Nash equilibria or equilibrium, it lies in the intersection point of the best response functions. So, our task is to find out the best response functions and then try to see at what point the best response functions intersect. So, to do that, what we need to do is that we are going to look at the preference or the payoff function of the players and try to maximize that payoff function, because that is what the players are doing. And then we shall get the best response functions, because what is the best response functions? It is that it gives me, for a player, gives me that action of that player which is best for him given what the other players are doing. So, if we maximize this, with respect to Qi, then we shall get the best response function of this player I. And so, we get the best response functions of these two players, there are only two players here, and try to find out what is the equilibrium. So, that is the strategy of approaching this problem. So, here if I look at suppose player I, his payoff function is what? It is Q1 multiplied by P, which is a function of Q1 plus Q2 minus C of Q1, and this is equal to alpha multiplied by minus Q1 plus Q2 minus CQ1. Now, from here I can take Q1 common, and what I get is alpha minus C minus Q1 minus Q2. But remember, this is going to happen if capital Q is less than equal to alpha. So, here it means that Q1 plus Q2 is less than equal to alpha, and this is if Q1 plus Q2 is greater than alpha, then this part, the first part becomes 0. This first part becomes 0, and then the second part is just minus Q1. So, it is minus CQ1 if Q1 plus Q2 is strictly greater than alpha. So, this is the profit function of player 1. So, similarly for player 2 it will be Q2 multiplied by So, the next task is to maximize either of these functions and find out the best response function. So, we are going to maximize subject to Q1. Now, if I do that, what do I need to find out? What are the first order and the second order conditions? So, what is the first order condition? The derivative of this is 0. So, if I take the derivative of this has to be set to 0, and so alpha, I am just using the product rule, and I have to express Q1 as a function of Q2. So, this becomes alpha minus C minus Q2 divided by 2. Is the second order condition satisfied? Well, what I need to check is that this has to be less than 0. and is this less than 0? This is nothing but alpha minus C minus Q2 minus 2 Q1. This is coming from here, second line, and this is nothing but minus 2, which is less than 0. So, the second order condition is satisfied. So, the first order condition which is giving me this is the best response function. So, the best response function of producer 1 is Q1 this. Now, one has to be careful as to what is the range, for which this is true, because if you remember here there was some range, but does the same range apply here also? Let us check that out. Remember the profit function. If I draw the profit function, how will it look? The profit function is this. Now, if Q1 is equal to 0 or Q1 is equal to alpha minus C minus Q2, profit is equal to 0. That we have seen. That is clear from this profit function itself. If I put Q1 is equal to 0, the first element is 0, so the entire thing becomes 0. If I put Q1 is equal to alpha minus C minus Q2, the second term becomes 0, which means again pi 1 is equal to 0. So, if I have to draw this curve, how will it look? Suppose I represent this Q1 along the horizontal axis and pi 1 along the vertical axis, and I also know that this thing is true. Which means this curve, pi 1 curve is a concave curve, and it is a concave curve and it is cutting this horizontal axis at 0 and at this point. Suppose this point is alpha minus C minus Q2. So, it is going to be like this, a concave curve which is cutting the horizontal axis at 2 points, and there is a point at which it is reaching its maximum value, and that maximum value is alpha minus C minus Q2 divided by 2. But I know that if Q1 exceeds alpha minus C minus Q2, then this profit is negative, and in that case the firm 1 will not produce anything. So, this best response function that I found out is true only if alpha minus C minus Q2 is either 0 or positive. If it is negative, then the firm is not producing anything. So, best response function will be alpha minus C minus Q2 divided by 2 if alpha minus C is greater than Q2 or equal to 0 if alpha minus C is less than Q2. So, this is what is the best response function of player 1. We shall proceed from here in the next class. So, before we finish this lecture, what we have done here is the following. We have introduced the idea of Cournot model of oligopoly. We have tried to find out what are the main aims of studying the Cournot model of oligopoly. We want to study the equilibrium in this model and how this equilibrium is affected by changing demand condition, changing cost conditions, changing level of competition. All of this we are going to study here, and in doing so we have seen that what we are going to do here is to find out the best response function and then try to see what is the Nash equilibrium. So far we have found the best response functions. In the next class we are going to look at the Nash equilibrium. Thank you. Explain the idea of market equilibrium. So, what happens in a market equilibrium? If we have a market, then there are basically two sides in the market. Buyers demand goods. Okay. So, we shall call it the amount of goods that they are demanding will be called QD, and there are sellers who supply goods, and this we shall call it as QS. Now, in an equilibrium, these two must be equal. That is QD, the amount of goods the amount of goods that is being demanded in the market at a particular price must be equal to the amount of goods that is being supplied in the market at a particular price. If that happens, then we shall call that situation as an equilibrium situation, because that is a situation of state of rest. Second, introduce Cournot oligopoly model. In case of disequilibrium in the market, what is or are the variables or variable that adjust in this model. So, Cournot model, Cournot oligopoly model. So, there are basically many sellers, but not infinite. Let us say n in number. N can vary from 2 to any number which is less than infinity, but not a large number also. There are n sellers in the market and they sell similar goods. Let us say sell homogeneous goods. And at a price. Since the good is homogeneous, the buyer cannot make out whether the good is coming from seller 1 or producer 1 or producer 2. So, the price for each of these producers, the price that they will get for each unit of a good is going to be the same. That is why we are saying that it is at a particular price. What adjusts if there is disequilibrium? If suppose demand is not equal to supply, then what adjusts in this market is the price. Price is the adjusting variable. Okay. Last question. What do the producers maximize in Cournot market? Find the best response of firm firm 1, whose cost function is Q1 square and which faces inverse demand function P is equal to 2 minus Q1 minus 2Q2. So, what do the firms do in Cournot competition? Firms maximize profits. This is our kind of benchmark assumption, though there could be variations in this. We can sometimes say that they maximize not profits, but output, or maybe maximizing their market share, but this is the kind of benchmark model that they want to maximize profits. Okay, now let us take this particular exercise. If firm 1 has cost function Q1 square and the inverse demand function is given by 2q1 minus 2q2. This is the demand function, inverse demand function. Now let us suppose that pi 1 is firm 1's profit. This is nothing but P multiplied by Q minus the cost function, okay, and this is 2 minus Q1 minus 2Q2 minus Q1 square. Now this is supposed to be maximized by firm 1. So the first order condition is this. From this we shall get this, and if we simplify this, then what we get is Q1 is equal to 1 minus Q2. Now this is true if this thing within the bracket is positive or 0, that is if Q2 is less than or equal to 1. If Q2 is more than that, then obviously this is going to be negative, which is not possible. So we are going to assume in that case Q1 is equal to 0. So that's it. Thank you.